The only people who don't want to disclose the truth are people with something to hide.
Expert, substantially more than 50 million cubic feet of gas below surface near giant sinkhole. Covers over 2 square miles, enough to do very serious damage. New flyover footage posted. Gary Heckox, a geologist with CB&I. The gas currently covers over 2 square miles. The extent is not well defined. The gas across here is between 2 and 10 feet thick, around 50 to 60 psi pressure. It is enough to have large volumes come to the surface very rapidly if it's uncontrolled. It's enough to do very serious damage to anything on the surface if it's not controlled. In the last month we've identified 20 new bubble sites on the western side of the sinkhole. We believe this is related not to necessarily more gas coming up, but we can't exclude that as a possible contributing factor. We've estimated the volume of gas in the MRAA as 50 million cubic feet in place. The picture says 200 million, that was a typo on my part. We'll have an updated estimate probably by the end of next week, and it's probably going to be substantially bigger than the 50 million.
Still ongoing. This is not finished. I'm going to play a little animation here so you can see, if I can find the mouse, there it is, just how the sinkhole has changed over time. It started off, the first profile was run the 1st of October. It was 450 feet deep, and you can see it had a very narrow cylinder down to the middle. 2 weeks later, it had shallowed to 150 feet at depth. 2 days later, it had shallowed to 100 feet in depth, and we were thinking, okay, it's starting to fill in. By the middle of September, or of November, it was still 100 feet deep. Then the first part of December, it started getting deeper, with the deepest point at 410 feet. The most recent survey, the first part of January, it was over 200 feet deep. So the bottom of the sinkhole is changing all the time. These are just some of the cross sections, so you can see a south to north and an east to west cross section. You can see how the bottom changes. It goes up and down. This is related not just to the burping, but also the continued activity in the disturbed rock column. As the rock is settling, the sinkhole gets deeper. Once it slows down, the sloughing from the sides fill it in, but then the activity starts up again and it gets deeper. So the sinkhole is kind of a micro sensor of what's going on in the 5,000 feet of disturbed rock below it. The sinkhole burps. It burps every couple weeks. These are strong indication of voids that fill with gas and then release. On the 19th of January, we were able to monitor quite closely. We were doing real-time analysis with people out there. We were watching all the instrumentation, and this is the first time we've ever been able to get conclusive data on one of these burps. And this was a large burp that moved probably on the order of 20,000 cubic feet of water at least. We don't know how much gas, because we don't know how much gas, what the pressure was. But the good thing about this burp, even though it was a large burp, it appears that the sand and gravel that's in the bottom of the sinkhole breaks up a large gas bubble into many small bubbles, just like an aquarium air sparger that's going up through the aquarium sand and gravel. And so we know we're getting a lot of gas coming up, but the sand and gravel's breaking it up, so you can't get a single bubble to the surface. And that is a good thing, because if you get a single bubble up and have an ignition source, you can have a flashover. But if you break it into millions of little bubbles, it comes up and you see it and everything. But it's my concern about large gas bubbles coming to the surface were much reduced after this event, because it looks like we got a little bit of a break. The sand and gravel in the bottom of the sinkhole is breaking up the big gas bubbles. They're still there, they're still happening, but we've got a little advantage that it's full of gravel. We monitor these burps on the very long period events in the seismic record. I will show you an example of one of those in a few minutes. We can calculate the volume of void space related to these burps because we get instantaneous changes in the level of the sinkhole, where a burp happens and the water falls and comes back up, and in the slide you can see two of these burps where you get instantaneous changes, and you can do a little calculation, figure out how big the void space is. So we know the voids are down there. I'm going to address now the gas in the Mississippi River alluvial aquifer. This is one slide out of sequence in your handout, but I think it will fit better with the presentation. The gas is coming up through the damaged rock zone, as we call it, and initially we thought it was getting near the surface and spreading out underneath the clay that's at the surface. The new data we collected from the 1,000-foot core hole has caused us to revise this. We think what's happening now, instead of the gas coming up in a point and spreading out, the gas is coming up in the sand and gravel in the deep part of the MRAA, and over on the west side, the MRAA is down about 600 feet. Very permeable. The gas is actually flowing through this gravel, and then the gas is coming up vertically and is captured by the clay at the top of the aquifer. And so it's kind of, again, like an aquarium where the gas bubbles are coming up everywhere. And this explains why we've got such a uniform distribution of gas below that upper clay. It was real perplexing for a long time. Why weren't we seeing a lot of gas near the sinkhole and very little over by the community? The reason is we think it's coming up vertically through the MRAA. And then, of course, unfortunately, it gets through to the surface, and you've seen the pictures of those in the bubbles, in the bayou, and in the community. The gas currently covers over 2 square miles. The extent's not well defined, but we're actually using some of the data from the ongoing shot hole drilling and the 3D seismic to further define that. The gas across the area is between 2 and 10 feet thick. It's generally under what we call hydrostatic pressure. It's around 50 to 60 psi pressure, which doesn't sound like a lot if you're into gas drilling, but it is enough to have large volumes come to the surface very rapidly if it's uncontrolled. It's enough to do very serious damage to anything on the surface if it's not controlled. We are venting in one area. We've been venting for a long enough time that we've actually got the pressures down in the MRA. Unfortunately, we're still not seeing an associated decline in pressure in the very shallow wells we've got installed. So even once we get the pressures in the MRAA down with all the new vent wells, it may take a longer time to actually get the pressures down below the homes. In the last month, we've identified 20 new bubble sites on the western side of the sinkhole. We believe this is related not to necessarily more gas coming up, but we can't exclude that as a possible contributing factor. But we think what's going on the western side of the sinkhole, that upper clay is fracturing as things settle into the disturbed rock zones. So we think it's related more to cracking in the upper clay than more gas coming in. Right now, we've estimated the volume of gas in the MRA at 50 million cubic feet in place. The picture says 200 million. That was a typo on my part. But right now, we've got a lot of new data, and we'll have an updated estimate probably by the end of next week on the volume of gas in the MRA, and it's probably going to be substantially bigger than the 50 million.
We'd like to remind the members that you will have opportunities to ask questions. I would ask that we, again, move as quickly as possible. And I know that Commissioner Donlan from the State Insurance Department is here and has a very limited schedule. We want to hear from them. So any concluding remarks, then we'd like to hear from Dr. Hatch.
I'm a doctor.
Good.
Oh.
Okay, Mrs. Peggy?
I'm a doctor now. Thank you.
Well, you know what? You look doctoral. How about that?
Thank you. I'll be very brief. I don't have a presentation. Our involvement began in July, and we have assisted Assumption Parish, GOSEP, DNR, Conservation, any way we can throughout this event, and we're continuing to provide assistance. Our primary mission is to provide environmental monitoring of the air and water around the community in Bayou, Corne, at the bubble sites. We have also monitored indoor air of 51 residents. We have ambient air around 98 residents also. Our mobile air monitoring lab has been deployed to Bayou, Corne, and it has the capability of not only driving around and doing real-time data, real-time sample data, but also we have mass spec on board, and we've analyzed canisters for any contaminants, and we have not seen any from the air. I do want to point out that, as Secretary Shute stated, federal agencies have been very involved. Do I look funny with these glasses? Is that what y'all are looking at me? I'm not used to them. And our primary agency that we've been involved with and have kept involved with through conversations, through meetings, has been EPA. They've been very helpful in providing any assistance that we've requested. We're also continuing to assist with and oversee the placement and the installation of the water control structures. I think Secretary Schute's covered that in the near the sinkhole. And I'm done.
Thank you so much. And members, what we're going to do to give you an opportunity that you're current, we're going to bypass for the time GOSEF, the Department of course we just heard from Mrs. Hatch, but the Shaw Group, and we're going to go directly to Texas Brine at this time. We'll ask those who represent Texas Brine if you would come forward and make your presentation. As you come forward, if you would, gentlemen, if you identify yourselves for the record. Gentlemen, welcome, if you will.
If there's a blue pill and a red pill, and the blue pill is half the price of the red pill and works just as well, why not pay half price?